delighted to introduce Cecile de Bezenac, who's our next speaker in the Causal Inference Interest Group seminar series. She is a doctoral student based jointly at the University of Leeds and the Alan Turing Institute. And her research examines the use of multi-agent simulations for the analysis of uncertainty and causal spatial models. And she has a background in civil engineering and demography. So over to you, Cecile.
Thank you, Peter. So today I'm going to present this very informal sort of introduction to spatial causal inference. So my project is in multi-agent simulation, but this is not what I'm going to present today. I may talk about it at the end of the presentation if I do have time. So the idea is just to give you a sort of general feeling of what spatial causal inference is, or could be, I guess, and to look at a specific example, which is neighbourhood effects. So to start off, how does this work? You've already seen the slide, but to start off, I just wanted to give you this example. So maybe some of you know what the Glasgow effect is. It's this effect that related to the excess level of premature deaths in Glasgow compared to Liverpool and Manchester. So based on some sort of aggregate socioeconomic variables, there was this excess level of deaths in Glasgow, and this was interpreted as some sort of inherent city level effect. Obviously, speaking of this Glasgow effect has certain issues, one of them being what does it actually mean for some theoretical objects such as a city to have an effect? And another issue, probably more concerning, is well, the fact that it's become some sort of media effect, had repercussions on population stigmatization, investment in the city, labor market, housing market, and all of these effects obviously did not contribute to reducing any sort of so-called Glasgow effect. So an interesting question for me in this example is why are Liverpool and Manchester relevant reference points to analyze causal effects? So what are the properties of these cities that make them comparable to Glasgow? And are any of these properties spatial? So I'm going to start off by presenting what spatial causal inference is. And I'm kind of new to this topic, so I'm going to kind of bring you through it the way I explored it, and I'm still exploring it. Then I'll try to branch out to a specific case, which is neighbourhood effects, and talk about the links with social interference. And hopefully in the end, I'll just quickly talk about my approach and how it's linked to this problem. So what is spatial causal inference? I'm going to start off by quickly going over what causal inference is. And I guess everyone might be familiar with this here, but the idea is kind of just to highlight what makes it very different to classical approaches. So first of all, the objective of causal inference is to explain and understand some sort of social reality. And the ambition is to make causal claims and not associational claims. So the analysis is really all about setting the conditions for the interpretation of causal effects. It's here kind of to guide the discussion and the interpretation. Ultimately, what we want to do with these estimations is ask what-if questions. So there's this underlying idea of intervention there. So the potential outcome framework is a very useful tool that's been used to think about causality and causal relations and to quantify effects. Basically, what I want to note with this is that effects are described as contrasts. So in a way, it's the difference in outcome between two scenarios for a given individual. Obviously, fundamental problem of causal inference is that only one of these potential outcomes can be observed. So the whole point of causal inference is finding the right set of conditions. So this could be the value of different attributes in order to actually make different observations comparable. So what makes all of this spatial? What is causal spatial inference in a way? So very broadly, it could be defined as a context in which the spatial configuration has an impact on the results. So different spatial attributes will somehow block the path between T and Y, so the treatment and the outcome in the causal structure. And here I'm voluntarily vague on what this space means. So it's S is just some relevant spatial information. So the fact that location matters and that space matters can be quite straightforward in some contexts. So for instance, if you think about a fast train between Leeds and London, it seems quite intuitive that the impact on the population mobility would be different in Leeds and in London. Curiously, however, introducing space in causal analysis or causal thinking in spatial analysis is quite a recent research field. So it's still at infancy. However, it does use tools that have been developed for spatial analysis, and these are not necessarily new. However, the focus in research is not so much on how these spatial representations relate to causality. So why is it important to include space in causal analysis? Well, as we mentioned before, some questions are inherently spatial. So sometimes these effects are very obvious. So when you talk about mobility, cities, climate change, there's obviously a lot of geography going on right there. Sometimes it's less obvious. So if you think about deprivation, infection, physical activities, social activities, behind all of this, there is some spatial considerations, and depending on the question, it could have a big impact. So overlooking anything related to space can lead to bias, and it can also lead to loss of information if the estimates that are used, for example, average over space. Specifically in the spatial analysis, obviously, adopting a causal approach is always very important because it's a guide to interpreting the results. And very often in classical approaches, the estimations are considered as effects and they are interpreted as such. And this, of course, can impact policy, public opinion, and future research, as we see in the Glasgow effect. So I'm going to present a little bit about what we mean by space, because spatial configurations can be very different and quite vague. So what is space, basically? Space can be seen through spatial objects. So there's different kind of objects. And in 2D, for example, you get points, point patterns, lines, polygons, and areas. All of these spatial objects have spatial attributes, and these are related to their position and to their morphology. So this can be size, their shape, or their structure. From these different spatial attributes are derived spatial relations between different objects. So these are either categorized as similarity relations or connectedness and separation relations. So similarity relates to the comparison of spatial attributes, so the morphology comparison of space, shape, and structure. And separation relates to the relative position between two objects. So this can be described as distance between 2 points, as an overlap, as touching or not touching, so whether they're adjacent or not, as intersection, and as inclusion. What I find kind of interesting here is that in these spatial relations, there's this idea of directed and undirected links. So for instance, the relation containing is a directed relation between the container and the contained. So in practice, what is done with this sort of theoretical spatial background, and how is it used in analysis? So of course, this will depend on the data that's available and also on the specific question that's asked. In geography, so the data that's most commonly used is linked to locations. So we have coordinates sometimes of points. We also have grid coordinates or postcodes, for instance, whether a point belongs to an area or not, and other kinds of relative spatial positions. The spatial relations that are used require choosing a specific measure or way of quantifying these relations. So for instance, a distance will quantify separation between 2 points, but the researcher will need to choose what distance they want to use. We'll need to choose what area they're going to use. So what does the inclusion mean? And also what does touching mean? So is it being connected by a link in a graph? Does it mean sharing a specific length of border, etc.? So all of this requires strong assumptions to be included in any statistical analysis. So more specifically in terms of the causal structure that's described by the potential outcome or the causal diagram, what is the role of space and how does it integrate into the structure? So for one, space could be in the treatment. So this is what we call spatial treatment. So it's a treatment with spatial attributes that could be position, size, etc. And the individual exposure relates to the spatial relation that an individual or an observation has with this spatial intervention. So this could be separation, overlap, inclusion. So for instance, if an intervention such as a medical center is at a given location, an exposure might be the distance to that medical center. Space is also seen as a confounding effect. So something that needs to be adjusted for. With space comes a lot of different variables and complex processes, and they're not always observed. So adjustment can be complicated if it's not observed. What this relies on mainly is strong assumptions on the spatial structure of the confounder, and it's about counseling basically these effects. For instance, by choosing controls and treated that are in close proximity, or by subtracting outcome values of neighborhoods to subtract somehow the spatial confounding. Finally, space can also be seen as an effect modifier. And by this, I mean that it doesn't have a direct effect on the exposure or the outcome, but it does have an impact on the effect of the exposure. So in causal analysis, this might be seen as a causal interaction and be treated through some sort of spatial stratification. More generally in spatial analysis, this is what's called spatial heterogeneity. And this is usually overlooked, or there are some methods that are developed that kind of represent this as a spatial field, and that use, for instance, Gaussian processes to estimate this field. I'm still not clear on exactly how this sort of estimation can be interpreted causally in any way. So the integration of space in this causal structure obviously introduces challenges for the estimation of these effects and the interpretation of the results. So for one, defining consistent spatial treatments is not very straightforward because this requires deciding what this spatial exposure is. So also what the spatial attributes and what the spatial relation is. And it requires finding relevant contrasts, so defining what a control is. For instance, if we think about the example of a medical center, if the exposure is distance to the center, then what's a control? Is it further distance away? Are we comparing things that are near to things that are far? Or are we comparing the fact that there is a treatment or to the fact that there isn't? So all of this kind of complicates the definition of what this treatment or exposure is. Finally, we said that spatial attributes could be seen as confounders, and what's the issue with this is that very often these are unobserved. So for instance, integrating space in the medical center issue could lead to confounding through the existence of sport facilities, for instance. Interference is another problem, and this is something that I'll develop later on in the presentation. It basically refers to the non-independence of units. So the fact that, for example, a treatment of an individual might have an impact on the outcome of a neighbor. And finally, another issue is the direction of causality. So it's not very clear sometimes if spatial relations lead to mediation or to confounding. And obviously that will change the nature of the estimate. So all that to say that it's quite difficult to design an estimation strategy when space is included. So what I take away from this, as I'm sort of discovering this field as well, is that it's a new field of research, but it presents quite interesting prospects, especially with the development of spatial complexity science and new types of data. The role of space is very difficult to define. So more than just a variable that you can add into a model, it's a medium for causal relations. So it could be seen a little bit like time. And a question that I find quite interesting is how do these spatial relations relate to the temporal causal relations that we're used to dealing with. Strong assumptions are made to include spatial dimensions in models, and these are actually rarely discussed in the literature. So for instance, a study might integrate some sort of spatial dimension, the spatial dimension usually, but it's never really, alternatives are never really discussed, and the theoretical decisions that actually are behind this dimension is never really linked to the uncertainty of the results. And this is actually what I'm interested in my PhD, is the uncertainty linked to spatial mechanisms, and in particular what we call neighbourhood effects. So the fact that some sort of specification of neighbourhoods, so the different spatial attributes and spatial relations that are linked to spatial neighborhood effects could have an impact on estimation. And how should these effects then be interpreted? So now this was meant to be sort of the focus of the talk, but I'll try to go quickly over it, seeing the time. The idea here is to present one of the issues I mentioned above, which is interference, and specifically the problem of social interference in causal analysis, and relate this to social interaction and to neighborhood effects, and see how neighborhood effects are used to approximate social and spatial interference. And then, of course, I'll talk about the challenges that this implies, and concludes with the objective of my PhD. So just for a reminder, interference, the no interference assumption is one of these assumptions that, that is needed in causal inference to actually identify, for the effects to be identifiable. So this implies that peers do not have an impact on others' potential outcome through whichever attribute. So the idea is an outcome will only depend on direct treatment of the individual. Of course, in a social setting, this assumption is very often too strong, and peer treatment do affect other outcome because there are social interactions. So this social interference is generated by social interaction with the social structure and some sort of element of transmission. And this will lead to sort of higher level causal mechanisms between the variables of the different observations. And of course, this violates the no interference assumption and may lead to biased results if there is some sort of unconfounding between peer effects, peer treatments. So 3 different kinds of interference have been identified in the literature. Direct interference that relates peer treatment to individual outcome. Interference through contagion. So you can think about, for instance, infection, so where the outcome of an individual will influence the outcome of another. And finally, allocational treatments, where an individual is allocated to a group with other observations. So just to come back quickly to the potential outcome framework, what this means is that the outcome can't only depend on the individual treatment, but will depend on, I guess, most general possible, the entire treatment assignment in the population that is considered. So this is a problem, obviously, because there's an explosion of the number of potential outcomes, while there's still only one that is observable. So for estimation to be possible, there's need of, again, strong assumptions on how people interact and influence each other. So the interference neighborhood assumption implies that there is a restriction of who can influence an individual. So basically it's finding a subset in the population that will have an impact on I, for instance. So examples of interference neighborhoods can be co-location, friendship networks, households, and obviously neighborhoods. Then we need to define how these neighbors influence an individual or each other, and what it means to be exposed to peer treatment. So this is what we call the exposure model, and it really just refers to finding a function that will aggregate the different peer treatments or outcomes and sort of channel their effects. So generally, all these assumptions are able to reduce the amount of potential outcomes from 2 to the power of n, where n is the population, to 2 times the number of different exposure levels, which is very interesting. However, Oh, so this slide just shows that the estimates have to be adapted, obviously, to represent direct effects and total effects of the treatment. And you can see here that they include the exposure function in the estimate. So when this is possible, so when these assumptions are possible, it is theoretically possible to find unbiased estimates for average effects. And the problem is that in practice, it's very difficult to have any information on who interacts with who, and even more difficult to know exactly what these relations are and how people influence each other. So this is where the partial interference assumption comes in. What the partial interference assumption is really is just about putting people into groups. So it's saying that individuals have a reference group and they can interact with observations in that group, but not outside of that group. So whatever the underlying structure will separate these individuals in G1 and G2 and just assume that, well, if anything weird and social is happening, it's restricted to those groups. So examples of reference groups are households, for example, classrooms, and again, of course, geographic neighborhoods. And geographic neighborhoods are often used as reference groups when the question relates to area deprivation, to the impact of green spaces, to pollution, to housing, etc. And all of this leads to neighborhood effects in the analysis. But what exactly are these neighborhood effects and where do they come from? So in the literature, it's defined sort of as the independent effects of neighborhood on a number of different outcomes. And this is also called context effects in some research fields. So basically, the social interference we were talking about will lead to what we call contextual effects. So these are also called spillover effects within the neighborhood. And other spatial mechanisms will lead to integral effects. And together, these two will create what we call neighborhood effects. But the underlying question here is, how are these neighborhoods defined to actually reflect these underlying mechanisms? So what is a neighborhood? It's a spatial object, obviously, with a position and different spatial attributes. So with a given area, a shape, and structure, possibly. The usual rationale for the creation of these different cutouts will depend on the source of the data. So if it's administrative data, very often it will be linked to different population counts, the presence of different infrastructure. It could also be related to physical borders, to spatial patterns of population. So this could be the case, for example, in different voting areas. It could be linked to historical borders or consistent spatial properties, such as grids. So for those of you who know, there's the European grid where the data is consistent across countries. So the issues linked to the definition of these neighborhoods and to these spatial attributes are that, well, for one, the borders and the areas change through time because obviously population changes and population moves. So for practical reasons, these change. Also, there's no consistency across borders. So it's very difficult to compare results in different countries or different regions. And finally, there's not always empirical reality behind the definition of these spatial objects. So they don't necessarily reflect any social or spatial process, and they're not tailored fit to the research questions. Now, once these neighborhoods are defined spatially, they need to be represented by some sort of statistical form, in a sort of statistical form, in order to be integrated into the analysis. So how is this done? This is usually done by aggregating individual level variables into a neighborhood one. So this is the case, for example, with deprivation, health variables, age, etc. It's also possible to represent neighborhoods through aggregate spatial data. So this is not necessarily related to the observations themselves. This is the case, for example, for a different number of points of interest. So either a green space area, a number of shops, of restaurants, of transport nodes. And finally, neighborhoods can also be defined specifically by area level attributes, such as identity, investment into that neighborhood, an urban plan that's specific to that neighborhood. So now, what model are these spatial representations integrated into, and how? So there's lots of different ways to include space in statistical models. And I'm just presenting here the example of a multi-level analysis. And this is a very interesting model because it does enable some sort of variability in the spatial objects. So by integrating an additional error term, we're actually accounting for this sort of spatial variability that's not explained by anything else. So in this equation, there are different elements that represent very different levels of the analysis. So individual level variables will be included in order to control for the selection into the neighborhoods, because obviously observations are not randomly allocated to different areas. Area level variables, such as social economic variables, will be included in the model in order to explain the process of this neighborhood effect. And finally, this random effect, UG, represents this sort of unexplained effect that's perhaps inherent to the area. So in practice, in spatial analysis, both the area level coefficients and the random effects are actually interpreted as these so-called neighborhood effects. However, this, of course, presents several issues and challenges for interpretation. For one, there is confounding. So obviously, lots and lots of unobserved variables on the spatial level that can confound the effects. And there's also the risk here of complete confounding. So this happens when there's complete separation between different observations in different neighborhoods. And this will happen usually if there's complete separation. So for example, if one neighborhood is only women and one neighborhood is only men. So statistically, it's impossible to actually estimate anything. Interference is obviously an issue because it creates a dependence between the observations within a neighborhood that can't be controlled by individual level variables. So there's this sort of residual selection bias that's linked to the fact that people influence each other and interact. And finally, there's the problem of misspecification of neighborhoods. So the fact that, well, the spatial definition of a neighborhood does not reflect the real process. And this is the case, for example, if in partial interference assumption, where we'll just assume that individuals don't interact outside of the group. This misspecification, spatial misspecification, brings us to a problem that's well known in geography, which is the MALP, or I don't know how to pronounce that, which is the modifiable areal unit problem. So for those of you who are not familiar with it, it's linked to specific choices of spatial attributes. So an arbitrary or not choice for a scale on which the data will be aggregated, and also arbitrary choice of what are the borders. So how do you define who is in and who is out, basically? So just to conclude on this section, I still don't really know what neighborhood effects are. So this is still like a remaining question I don't feel I've answered. I think it's almost a conceptual one, is can a spatial object have an effect? And yeah, it's sort of the question of, should localized effects that are caused by different social micro-level mechanisms, can those be attributed to spatial constructs to be able to infer something causal? So the issue here is not really the data. I mean, although it does create limitations, but it's also the interpretation that we make of our results. Because as we've seen, biased results can have negative impacts on the area itself and actually create this almost real neighborhood effect in a way. So through media publications, I don't know if any of you have watched the show The Best and the Worst Places to Live in the UK. I don't think it exists anymore. But also through shortcuts in research. So this is quite common to hear researchers speak of, for example, neighborhood effects, for instance, as moving to this area will increase the chance of heart disease. And behind there is some statistical bias and scientific issues. So I think I do have time very quickly to kind of present my approach based on everything I've said. The questions I'm interested in are, well, for one, the relation between this misspecification of spatial mechanisms and spatial attributes and the misinterpretation of, or the different causal estimands. This is related to the uncertainty of the spatial approximations and the approximation of spatial interference by neighborhood effects. All that to say that all of these challenges, I'm not going to solve them, obviously, but I'm quite interested in studying the challenges themselves. So my general approach is using agent-based modeling to analyze the different sources of uncertainty in the simulation model, and then bring that back to the uncertainty of estimations. So questions that relate to uncertainty are, for example, how many possible mechanisms could result in the same sort of estimation by these classical methods? What are the possible worlds that would be generated given effective neighborhood effects? There's also an underlying idea of sufficiency of the statistics. So for instance, are the spatial treatments correctly specified to actually be able to discriminate between competing causal mechanisms and underlying processes? The underlying general question that multi-agent simulation is able to sort of ask is, what is the relation between causal dependencies? So the more general causal structure we're used to dealing with, and causal mechanisms, which are the micro level processes that actually lead to these causal dependencies. And I think I'll stop here. if you have any questions on that. Thank you.
Thank you very much, Cecile. That was a very interesting talk with a lot of different elements to it, and hopefully lots for people to think about. Obviously, at this point, we would like to invite anyone who has any questions about any part of the talk, really.
You're welcome to either unmute yourself to ask a question, or you can also post your question in the chat box, whatever you're comfortable with.
I have a kind of, while we're waiting to see if anyone else is going to ask anything, I have a kind of a couple of sort of practical thoughts. There's a lot here in terms of understanding what's going on, and I think it's pretty obvious that it's pretty complex. Do you have a sense of how much this complexity and these issues have been considered within the existing kind of spatial research community, particularly the applied community, or is it something that's only beginning to filter through, that perhaps we need to, the analyses that we're doing, really, there's a lot of assumptions going on?
Yeah, I mean, there's always going to be a lot of assumptions, I guess. So actually, it's quite a recent field of research. So the idea of kind of putting together the words spatial and causal inference, that's pretty recent. Simply because causal inference, well, for one, is also recently kind of seeping into all the different research fields. Also because it's complicated and it's complex, and because there are obvious data limitations that make it difficult to actually control for spatial elements. So yeah, it's something it's considered to be in the literature a future challenge, I guess, for geography at least, is to sort of create and define a framework to think causally about spatial results.
Yeah, I think that sounds fair enough. It certainly very much sounds like a challenge that will take a lot of thought by a lot of people over many years. I think we have a comment or a question. I'm just going to read that. I guess space maps into time when you have a signal that propagates like sound or an earthquake. Infection is much weirder as the process involves people encountering, and so has a lot of randomness. I think that's more of a comment, but I noticed somebody's put their hand up.
Sorry,
so we'll
interrupt. We had someone ask a question in the Q&A first.
Oh, I missed that.
Oh yeah.
Yeah, please jump in. Yes, I missed that. Georgia, do you want to read that?
I will. So the question is, I am just a bit confused about the causal aspect of the neighborhood effect, which I feel it's more of a contextual mechanism or process. Could you please elaborate a bit more about that?
Yeah, I'm actually quite a bit confused as well, because the causal nature of neighborhood effects is not clear at all. The problem, I guess, and the issue that relates this to causal inference is what's been done with these effects and how it's been interpreted. So in spatial analysis, these effects, and such as the Glasgow effect, or the effect of some neighborhood that's some perhaps poor neighborhood on health outcome, is interpreted causally, because the sentence moving to X will increase chances of some sort of health hazard. That's a causal claim. So that's essentially where causality comes into neighborhood effects. And I agree that it's not very clear if we can actually interpret it causally at all. And that's kind of the whole point, is that I personally don't believe it has any causal quality, I guess, because it's some sort of theoretical objects that we're mapping onto some social and spatial reality. And we're trying to give it some causal. I guess it helps us understand things, and also the data is only available on the neighborhood level. So I guess we're doing the best we can. So I guess my take is that, okay, we won't really know if there's some sort of inherent neighborhood effect, but we could analyze what the effect of the definition of the neighborhood would have on estimations. And if you're referring to, maybe you're referring to the model, the multi-level model when you speak it. I don't know who asked the question, but.
There isn't any follow-up there, I'm afraid, but your answer actually kind of answers what was going to be my second question anyway, which is about the interplay and the amount of causality that we can attribute to these different elements, how much of a spatial variable you suspect is likely to be a summary of a lots of underlying microprocesses that are taking place at the individual level that we kind of can view and summarize, but there's big problems with that summary kind of approach. And how much we think there are these true neighborhood processes taking place. I think that's really fascinating. I'm going to jump into the person who has their hand up, which is Namid. If you want to unmute and ask your question.
Yes. So this might be a very stupid question, so apologies, but just trying to get my head around this. So the way I was trying to kind of separate this out is that it's very heavily related. I think you alluded to this, of stratification, and essentially what kind of groups we're applying to the different individuals, and especially in the context of agent-based models. I mean, in a way, it's relevant to the properties of an agent. So it's one way to explore this, to consider different levels of stratification. So in a very kind of geographically heavy analogy, whether we're looking at treatments at the scale of an entire country, and then looking at the difference, keeping the underlying causal mechanism or network fixed across different simulations at different scales, and then estimating differences in observed outcome. And I suppose related to that kind of attempt to get my head around it is also, I think the way I'm thinking about it is from a very individual specific way, but I also think lots of your descriptions here is more about the treatment effect, and how exactly do you uncouple those two, and whether that's even possible.
Thanks. In your last question, what do you mean by treatment effects versus? Sorry.
So more almost the interactions between individuals, or for example, external effects on an individual, rather than just, which I guess is also quite hard to disentangle.
Exactly, and that's why it's sort of a problem, because treatment effects. So, for example, if you consider, I don't know, neighborhood effect to be the treatment effect you're looking at. So, what is the effect of moving these people to this neighborhood? Essentially, it's a treatment effect that you're looking at, but behind there are spatial interactions. So it's the fact of kind of aggregating these interactions into some sort of spatial treatment effects on a higher level. That's kind of the issue. I don't know if that answers your last question.
I think so, yeah.
And as for, so your first one was, what would an agent-based model approach be?
Both that, and also just how, like, is it the correct way to think about this, that to explore it is to explore different levels of spatial resolution? So keeping the causal mechanism fixed, and then looking at, for example, a treatment that doesn't account for spatiality, and one that is much more heavily conditioned on spatiality.
Yeah. So that's kind of what's interesting about multi-agent systems is that it's not just a simulation. First of all, you can simulate a complex system and it can be dynamic. And it's also the way you define your conditions that are quite straightforward. So this is something I guess agent models could do. The problem, of course, is how also you interpret what the agent-based model is giving you. And that means, of course, having assumptions on what this causal structure is and how the space affects the causal structure. But essentially, that is the idea. It's sort of a lab, if you will, where you can just, put all your assumptions together, take them out and put them back in, and then just turn things on and off and kind of observe the effects. And that's why it's quite interesting to think about uncertainty. It might not give any real insight into what's happening in the real world, but it will give insights into what our assumptions are actually implying, I guess.
Yeah, that's really helpful. Thank you.
Thanks. So we have another question from Anna Freni. Starantino, I see you've unmuted yourself, so over to you.
Thank you. Thank you very much. This was very interesting talk, and I was really looking forward, so well done. Someone asked about causality in spatial, and I've been working in environmental epidemiology, and I can tell you that there are attempts to try to make a causality statement when it comes, for example, for a certain type of exposure. So the idea is that people usually try to mimic randomized experiments. And there's been a little bit of literature written around kind of like pollution or like heavily polluted areas. And basically you use the area that are polluted as the one treated, and you try to match with some other areas that are not as controls. And there is also a lot of stuff around using these quasi-experimental approaches. But I guess that this is kind of like a way around. The core of the problem with the spatial causality sits on the fact that we have to deal with the fact that in general, when you do statistical inference on space, what happens, so the linear relationship or the relationship that you find at an individual level not necessarily will reflect at the aggregate level. So that's one problem. The other problem is that, and this is something that it's really sitting a lot on people's mind, especially in policy, is to understand how different the treatment or policy will affect certain areas. So what is the causal mechanism that will work, for example, for England and will replicate the same causal mechanism for Scotland? So there is a lot of interest to understanding how those different treatment and policy or intervention, they will scale for different parts of population, but also for different geographies, which are nested. So there, you see that the problem can be seen in different levels, because you can scale it for different geographies that are in a hierarchical structure, but also for different populations. So
yeah.
So I think the agent-based modeling approach is the way to go, and I agree with you that maybe you will not find the solution, but you will start to understand what are the things that you need to check,
exactly.
At least to start to think about it, because even trying to generate something like this, it's super hard. So I guess that it's an interesting and new research field. Then
Thanks.
Good luck with the PhD.
Yeah, that is the idea. It's kind of using an AVM to kind of discuss the implications of our map, our spatial map, basically, because it's just a model, and behind that model there are a lot of assumptions that we're not discussing, And yeah, I guess it's you could see it as some form of sensitivity analysis, like when you have latent confounding and you can't do anything about it. Well, ABM can do that with different mechanisms, I guess.
I mean, if we had more time, it would be cool to explore the comment that you made about space and time in one of your slides, because, you know, time fits well in the way we are thinking about cause and effect. It's on like, it's what makes cause, because there is a before and after. In space, it's very hard to translate that, except for this kind of process that will, you know, it's like the infection or wave.
Yeah, of course, time, causal relations, how we see it, is time. I just thought it was interesting because there's sort of a similar substance, I guess, and I thought it could be interesting to explore how dealing with one could help dealing with the other. And it doesn't mean necessarily thinking about causation in a different way, but there's, I don't know, I think there's might be something to explore in terms of spatial relations and seeing it as a sort of, I don't know, field to think of causality.
We are crashing into the end of the time, and I'm aware that there is another person wanting to ask a question. Is it a 10-second question, John?
Well, it's just that I put some things in the chat which are examples of the connection between space and time. But the reason it's really brilliant what you're looking at is that actually it's an inverse problem, because the temporal relationship and the spatial relationships depend on the process models that relate those things. So your agent approach is, I think, absolutely on the money. And if you know something about the mechanism, then you can do some inference about what's the relationship of space and time. But if you don't know much about the mechanism, you may be trying to learn it, then it's really complex. So I think it's a really cool talk. Thanks so much.
Thank you. Thanks for your comments.
That's a perfect comment, I think, to bring us to an end. It's 4 o'clock. I'm aware that people are already leaving. Thank you very much to everyone who has joined. Thank you especially to Cecile for a very interesting and thought-provoking talk. No doubt the conversations will continue in the years to come. Yes, George has just posted details of upcoming talks can be found on our mailing list. Thanks again, Cecile.
Thank you. Thanks for having me.